Hi, Dr. Tillman. This is Carson. This is my 382 project, and I'm just going to be going over the couple slides I put together, and then I'll run you through my code, and we'll look at the results. So the task at hand, the goal for this project was we're going to cover Fourier series. We're going to look at Fourier series representation of just an arbitrary periodic signal. We need to find the coefficients for that signal in order to compose a nice looking graph for that signal in order to get a more accurate approximation. And then for the part two, we find the bandwidth of a signal, and then if 95% of that energy is being transferred, what would that bandwidth be? So for the first part, of course, we need to find the Fourier series coefficients. This was on using the equations that you gave us throughout the course. We then converted those into working MATLAB code, which we'll go over and see here in just a minute. After those coefficients are calculated, they have to be summed up again in accordance with all the equations that we've been covering in the course. The equation you'll see at the top is the one that we typically use for your x of n, which is your Fourier series coefficient. And then at the bottom, you'll see this is the code I used, which again, we'll go over after all the slides are done. And then this is the summation equation again, and then the corresponding code here is basically what you gave us a few days ago in class, which turned out to be extremely helpful and cut down the time like a lot. So yeah, these are the results. On the left, we have the general waveform, and then on the right-hand side, we have your magnitude and your phase spectrum for both with the coefficient values. So for part two, again, we're just using and this time we need the Fourier transform, not just the Fourier series. We need to take the complex conjugate because, again, you stressed in class a lot that that's the easiest way to find like your magnitude of a signal. And then after that, we just run some calculations on it to find our bandwidth. So cool. Alrighty, so this is the code for the most part. Excuse me. Here you have your coefficient integral. This is again corresponding to what we looked at in the slides. Everything down here is just some basic like formatting. This is your stem plot, everything like that for your magnitude and your phase spectrum. This is the array for time. This is the index that you wanted us to go for. And then here's the code for everything else, like I said in the slides. So when we run it, runs pretty quick. Oh, grab it here. Sweet. So there you can see again, both the same as from the slides. And then for part two is very similar. We just here's our Fourier transform, actual integral, our complex conjugate. Those are mostly built-in functions. We take our total energy. Now we have what I like to think of as our partial energy, which is 95%. We evaluate the other integral, and we use the built-in solve to find our bandwidth from the equation that you gave us in the problem statement document. So there is your answer for your bandwidth. And then I forgot to do, yeah, my coefficients are right there for my Fourier series. Alrighty, and there you have it. Thank you so much. Your class has been very informative and I really appreciate it. Have a good one.